Okay, so lesson 342, we're going to go over the 4 examples in the PBT, and then you guys are going to have the rest of the time to work on your homework. Okay? So make sure that as we're going through this that you're writing down and following along. So we're going to use it. We're actually going to start with example 1. In each one of these examples, you're going to find the discriminant of each of these quadratic functions, and then you're going to use that discriminant to state the number and type of solutions, which you guys have already done before. It should be review. So it'd probably be best if you actually pause this and then just check your answers when you're done. So using the formula, or you could skip ahead to if you'd like, if you're just checking your answers. So using the formula, b squared minus 4ac, I'm going to go through number 1, 2, 3, and 4. I'm actually going to pause it and then just show you the answers. Okay, so in number 1, you should have gotten a discriminant of 49, which, because it's positive, means that there are 2 real solutions. Remember, your solutions are your number of x-intercepts that you have. So if you were to draw this function has a positive a value, which means your function would go up and it would intersect or hit the x-axis twice. Is number 2, because your discriminant is again positive, this means you also have 2 real solutions. The only difference is when you graph this one, you're going to have your a value is negative, so your function is actually going to open down when it hits the x-axis. And number 3, because you have a negative answer, your discriminant's negative, which means you can't take the square root of a negative, so you actually have 2 imaginary solutions. Remember, it's 2 because you have a plus and minus when you take this square root. So this means that when you graph your function, it will never hit your x-axis. Your function opens up. It looks something like this. And number 4, your discriminant is 0. Remember, because you're taking the square root of 0, square root of 0 plus or minus is the same thing. So that means you're going to have 1 real solution. So when you graph your function, that means your vertex lies on the x-axis. This function opens up, so it might look something like this. Okay. Alright, so the objective for today is pretty much what you guys just did, which is I can state the number and type of solutions to a quadratic equation by first finding the value of the discriminant. Again, I'll review. You don't need to write this down. You guys should have this written down somewhere unless you want to, but just remember that anytime that your discriminant is greater than 0, it means you have 2 real solutions. If your discriminant is less than 0, you can't take the square root of a negative, so you have 2 imaginary solutions, and if your discriminant is 0, then you have 1 real solution. If you were to graph these, 2 real solutions would look something like this. Here's a solution, here's a solution. If you have 2 imaginary solutions, it might look something like this, where it never hits the x-axis. And then 1 real solution is where the vertex is your only solution. So something like that. Alright, in example 2, the problem that they had didn't work out so great. So can you guys actually write negative 3x squared plus 12 equals 0? And then let's go through this problem. So we're going to solve this using the property of square roots. So that just means you're isolating your variable, similar to a linear equation. So first thing, we're going to subtract 12 from both sides. So you get negative 3x squared equals negative 12. We're going to divide both sides by negative 3. So we get positive 4. We're going to take the square root of both sides, and we get that x equals plus and minus 2. Remember, there's 2 solutions. So show that the quadratic formula gives the same solution. So here's our solution. We have x equals plus and minus 2. And then using the quadratic formula, we have x equals, you have no b value, so the opposite of b is just 0, plus or minus 0 squared minus 4 times your a value times your c value. Take the square root, divide everything by 2a, so 2 times negative 3. Okay, so when you simplify this, you're going to get 0 plus or minus, your discriminant is 144 divided by negative 6. Okay, and when you go through and you do the square root of positive 144 divided by 6, you get that x is negative 2. And then when you do the negative square root of 144 divided by negative 6, you're going to get x equals positive 2. So there's the same two answers. So check your solutions, explain how the graph of the related function supports the type of solutions. So given the fact that your discriminant right here is 144, this is positive, so this is where I know that there are two real solutions, meaning two x-intercepts, which I can see I found here. So two different ways of doing it, but I get the same answer both ways. Okay, so example 3. Solve this by using the quadratic formula, check your solutions, and explain how the graph of the related function supports that type of solution. So why don't you do this on your own, pause it, and then just make sure that you get the same answer. Okay, so you should get down to this point right here, which actually when you simplify, so this is a perfect square, so we're going to say that this is equal to negative 6 plus or minus 4i divided by negative 2. And then we're going to leave our answer like that because we know that our two answers are imaginary solutions. So if we were to graph this, we would know that because our a value over here is negative, our function is going to open down and it's never going to hit the x-axis. So it'll look something like this. And then this graph right here supports our answers, which are imaginary, and we've shown that we have no real solution. Okay? So in example 4, again, why don't you guys pause it, do the same thing, solve, and check your answers. Make sure that you set this equal to 0, so you should have 2x squared plus 8x plus 9. Make sure that as you go through here, you write these in order of a, b, and c, so you don't mix them up as you use the quadratic formula. So the opposite of b plus or minus b squared minus 4 times a times c. And then remember to divide everything by 2a. Okay, so simplify your discriminant. Okay, so we get negative 8 plus or minus. Your discriminant is negative 8 all over 4. Again, your discriminant right here is negative, so we can conclude that we're going to have two imaginary solutions. And if we graph this, we know that it would never hit the x-axis. Our a value is positive, so it'll probably look something like this. Okay, so let's move on to the PBT. Go ahead and change the function that they gave you. It actually works out really poorly, so we'll just use this one instead. Alright, so we're actually going to solve this equation by using three methods, the quadratic formula, the property of square roots, and also factoring, and we're just trying to show you again that all roads lead to the same destination, so no matter which method you use, you're going to get the same answer. Okay, so again, why don't you try, you should be able to do the quadratic formula and the property of square roots without a problem, so pause it, do both of those, and then you're probably going to have to check back in with factoring. Okay. Alright, so using the quadratic formula, you should get x equals, opposite of b, there is no b, so 0 plus or minus b squared minus 4 times a times c, square root all over 2a. Okay, so you should get 0 plus or minus b squared of negative 64 all over 4, which simplifies to 0 plus or minus 8i over 4, and we can actually take this a little bit further because of this 0 right here. The 0 just wipes out, so you're going to have a positive 8i over 4, which simplifies to 2i, and then you're going to have a negative 8i over 4, which simplifies to negative 2i, and that's all because of this 0. Okay, so there's your two solutions. If we check the answer using the property of square roots, remember, isolate your x squared. So the first thing you're going to do is subtract 8 from both sides. So we're going to get 2x squared equals negative 8. Divide both sides by 2. You get x squared equals negative 4. Take the square root of both sides, which gives us two answers. So x equals plus or minus, the square root of 4 is 2, and we know it's imaginary because you can't take the square root of a negative. So same answers as before, a positive 2i and a negative 2i. And then we really haven't done too many of these. But if we want to factor this, we know that there's no middle term. So we know that this is going to be a sum and difference problem. It's a little bit harder because of the fact that um, there's a plus sign right here. So let's first actually factor out 2 from both of these. So we're going to have 2 times x squared plus 4 equals 0. So like I said, we know that there's no middle term, so we know that this is going to be x plus and x minus. And then we know that the square root of 4 is 2. So we know that this is a 2 and a 2. The only problem is when I multiply a positive 2 times a negative 2, I get a negative 4. So the way that I make that then become a positive 4 is by adding an I here. Because when I multiply these two now, positive 2i times negative 2i will give me negative 4i squared. And remember, I squared is negative 1. So negative 4 times negative 1 is positive 4, which is what we wanted to get, a positive 4. So this would be what it is factored. And then if we solve this, we're going to get x equals, this one right here gives me a negative 2i, and then this one right here gives me a positive 2i. So negative 2i, positive 2i, I got it the same way on all of the methods. The easier method was probably this one right here, since we had to do some simplifying here, and then factoring was a little bit harder. Okay? Alright, so you guys should be good then. Your substitute is going to give you the review packet. You need to make sure that over the weekend you do numbers 1 through 10 and 20 through 24. Make sure that you get at least those problems done. When you come to class on Monday, you guys are going to work for the most of the period. I'll answer a few questions, and then by the time you come to class on Tuesday, we'll go over any questions that you guys have, review, and then Wednesday you take your Unit 3B test. Okay? Good luck.